Let us now study the detection of hydrocarbons using electrochemical sensors. What are hydrocarbons, what are polycyclic hydrocarbons, and why are the detection of these hydrocarbons necessary can be seen. So polycyclic aromatic hydrocarbons are widely found in air, food, and also soil and water. This polycyclic hydrocarbons, also referred as PAH, polycyclic aromatic hydrocarbons, these can be said carcinogenic and mutagenic. They are termed to be carcinogenic and mutagenic because they are very harmful, and once they enter the human body through diet, they cause vital effects. So after entering the body, the PAH or the polycyclic aromatic hydrocarbons, they get metabolized into hydroxy PAH. The polycyclic aromatic hydrocarbons get metabolized inside the body to form hydroxy PAH. So these hydroxy PAH, they are excreted from our body through urine. So this detection of hydrocarbons is highly necessary because of their harmful effect such as carcinogenic and mutagenic. Hence, in the detection of 1-hydroxypyrin, we take this as an example of one of the hydrocarbons and detect it using an electrochemical sensor. 1-hydroxypyrin is the commonly found hydroxyl polycyclic aromatic hydrocarbon which is present in various samples or various bodies. Hence, they need to be explored. They need to be found out from the human body and they should be monitored. For further ill effects, we have to study about this hydroxypyrin, which is one among the PAH, and detection of this hydroxypyrin is necessary. So, electrochemical detection occurs in the interface between analyte and the working electrode. As we all know, in the sensor, the electrochemical reactions occur between the interface, the surface of analyte as well as the working electrode. In detection of hydroxypyrin, we use working electrode, counter electrode and the reference electrode. As you could see, chromium containing metal organic framework are used as the working and counter electrode, and we know the general reference electrode which is to be used. So, chromium containing metal organic framework is used both as the working electrode as well as the counter electrode, whereas Ag bar AgCl, that is our general reference electrode. Now, coming to the working of our electrochemical sensor in detection of hydrocarbon, we have when a sample containing 1-hydroxypyrin is put in the sensor, what happens is oxidation of 1-hydroxypyrin occurs. So, at first, when the sample containing 1-hydroxypyrin is put in the sensor, oxidation of 1-hydroxypyrin occurs on the surface of the sensing electrode, and the reaction on the electrode surface causes the current to flow. Once the oxidation occurs, once the reaction takes place, then what happens is the current flows. The current produced is directly proportional to the concentration of 1-hydroxypyrin, but it doesn't stop as such. The final product leading to Now, let us see the reactions of 1-hydroxypyrin, which is being the example of hydrocarbons. In the detection of our 1-hydroxypyrin, the reactions are as follows. 1-hydroxypyrin, it undergoes oxidation and forms 1,2 dihydroxypyrin, which is further seen as pyrin 1,2-quinone. So this is the final product of formation which can be seen, which initially started with 1-hydroxypyrin, which got oxidized to form 1,2 dihydroxypyrin, and finally in the generation of pyrin 1,2-quinone. This is the product obtained because of the presence of hydrocarbon, which indicates the presence of these PAH in our body. So these are the reactions which occur in polycyclic aromatic hydrocarbons. Yes, now let us study the detection of dissolved oxygen using electrochemical sensor. As we all know, electrochemical sensor plays a vital role in the detection of various components such as hydroxypyrin, in detection of pharmaceuticals, in detection of various other factors, and whereas detection of dissolved oxygen is one among them. Yes, let us now study the application of electrochemical sensor in the detection of dissolved oxygen. As we all know, electrochemical sensor plays a vital role in detection of pharmaceuticals like diclofenac, whereas hydrocarbons like 1-hydroxypyrin, and we also use it in detection of dissolved oxygen where oxygen is present in its dissolved form. The oxygen present in water in its dissolved form is called as DO or dissolved oxygen. So, electrochemical sensor which are used in the measurement of DO are called as amperometric sensors or Clark type of sensors. They could be termed as amperometric or Clark type of sensors, and also galvanic sensors are also used in the measurement of dissolved oxygen. In electrochemical dissolved oxygen sensor, there are two electrodes. Generally in every sensor we use two electrodes. As in such, even in the detection of dissolved oxygen, we use two dissimilar sensors which are made up of dissimilar metals, where one consists of the anode and the other consists of the cathode, and with an electrolyte and a semi-permeable membrane. So this is of the construction which consists of two electrodes, anode and a cathode, as well as electrolyte and a semi-permeable membrane, which can be seen in the figure. And the anode is made up of zinc, or lead, and even cathode is made up of silver, and the electrolyte is KOH or NaOH. So we know it consists of two different electrodes and an electrolyte and a semi-permeable membrane, and the membrane used is Teflon. It is a semi-permeable membrane. So what happens in the working is the difference in potential between anode and cathode should be maintained of at least 0.5 volt. In the working principle of electrochemical sensor in detection of dissolved oxygen, our anode is made up of zinc or lead and cathode is made up of Ag, that is our silver. So let us know the working of electrochemical sensor. The potential difference between anode and cathode should be maintained of at least 0.5 volt. So at anode, what occurs is the liberation of electrons, that is, it undergoes oxidation, liberating electrons, and then the oxygen molecule, it occurs to undergo diffusion. It undergoes diffusion across the oxygen permeable membrane, which is the Teflon. So it diffuses on the Teflon, that is the oxygen permeable membrane, into molecular oxygen, and finally to produce OH minus at the cathode. So oxygen undergoes diffusion, that is, it diffuses because of the presence of this oxygen permeable membrane, that is Teflon, and it produces OH minus at the cathode. Then the reaction produces an electric current that is directly related to the concentration of O2, that is oxygen in its dissolved form, or it is called as DO. So the current is carried by the ions in the electrolyte and runs from cathode to anode, and finally voltage or potential is measured. Not the voltage, the potential is measured. The reactions are as follows, where oxidation is occurring at the anode, liberating electrons, and where oxygen is undergoing diffusion because of the presence of Teflon to produce OH minus on the cathode on the other hand. This is the working of electrochemical sensor in the measurement of dissolved oxygen. Let us now study the applications of electrochemical sensor in detection of toxic gases. We know there are several types of gases present in our atmosphere which are responsible for various greenhouse effects and acid rains, soil contamination, erosion, pollution, etc. So, in detection of SOx and NOx, that is the oxides of sulfur and the oxides of nitrogen, electrochemical gas sensor plays a major role. Then what is an electrochemical gas sensor? Electrochemical gas sensor is a type of sensor where the analyte is gas molecules. So here we detect toxic gases and take precautionary measures. So what do we do? In electrochemical gas sensor, what occurs is monitoring and concentrating the gases takes place. That is, like, we monitor the type of gas present in the atmosphere and the concentration of gas present in that particular region or area. Say for example, if I have to calculate the amount of toxic gas present in this room, this particular room, I would take a sensor and would check the amount of gas only in this area. So it is used as such. So the major contributors for air pollution, as we all know, they are sulfur, oxides of sulfur, nitrogen, carbon monoxide, CFCs, chlorofluorocarbons, H2S, etc. So these gases need to be detected. Electrochemical gas sensor does this job. Electrochemical gas sensor provides a cheap alternative method for air quality monitoring in the environment. This detection can lead to various other advantages. So it is also used in gas chromatography, there are very other methods like gas chromatography. Electrochemical gas sensors, they provide a cheap alternative option for air quality monitoring in the atmosphere, because whereas we know mass spectroscopy, IR spectroscopy as well as gas chromatography, they are very expensive, whereas this electrochemical detection is cheap and effective. So in the detection of oxides of nitrogen, that is electrochemical detection in the oxides of nitrogen, what happens is they are used to measure NOx concentration. When the gas analyte comes in contact with the electrochemical sensor, what happens is they measure, like when the sensor comes in contact with the gas analyte, that is your toxic gas, it measures the amount of gas. It detects the gas and there exists a change in resistance. As soon as the electrode as well as the gas, they come in contact with each other, there is a chemical resistance created. So once they react with each other, there is a chemical resistance created, which in turn is responsible to detect the amount of gas present and the concentration of gas present. So it's all about the formation of that chemical resistance, which is due to the interaction of your toxic gas as well as your, electrode. So when the sensor comes in contact with your analyte, there occurs the change in resistance, which in turn indicates the amount of product formed and the amount of toxic gas present in that particular region. What happens is the concentration of electrons decreases. The concentration of electrons decreases due to the presence or due to the reaction of electrons in the sensing material. The electrochemical gas sensor has the sensing material which senses with the analyte, so the electrons get depleting or decreasing, and what happens next is the resistance offered by the electrons decreases. We know current and resistance are the two factors which are inversely related. The one increases to bring the other down. So when current increases, there obviously is resistance which is decreasing, and when the resistance decreasing, there is obviously the current increasing. So we know resistance offered by the electron, when it increases, what happens? Current obviously decreases. But what is happening here? The resistance offered by the electrons, it is decreasing, increasing the current. So the higher the concentration of NO, that is the analyte, the gas, toxic gas, and we could find the lesser is the resistance. Higher the toxic gas, lesser is the resistance, higher is the current produced. So this is about the detection of NO. Whereas in the detection of oxides of sulfur, what happens is they work on the electrochemical principle. We know electrochemical principle is about diffusion, where the diffusion of gas occurs, where the diffusion of SO2 gas occurs. The diffusion occurs to form SO2 getting oxidized to form oxygen free radical. Your SO2 oxidizes to form oxygen free radical, and it also converts this oxygen free radical into molecular oxygen. So SO plus your oxygen free radical is obtained when SO2 gas is oxidized, whereas this oxygen free radical is converted into molecular oxygen. Then what happens? The sensor consumes electrons from the reduction of the number of electrons and then decreases on the electrode surface. Thus, resistance of the electrodes determines the concentration of SO2. The resistance offered or the resistance created due to on the electrode surface determines the presence of the concentration of SOx gas present in your given analyte. So it is all about the resistance created when the sensing element and your analyte comes in contact with each other. So what happens are the reactions which are on the board, as you can see. Electrochemical detection. This is about detection such as oxides of sulfur and oxides of nitrogen. We know sensors are classified into chemical sensors as well as biosensor. Based on the origin, if they are from chemical origin, they are termed to be chemical sensors. If they are from biological origin, they are termed to be biosensors. So these are the type of sensors which have biological origin and they can detect and measure bioanalytes. Biosensors are the type of sensors which are of biological origin and they can detect and measure bioanalytes. So the example of biosensors are use and throw or disposable sensors. Disposable sensors are also termed as use and throw sensors. One-time use sensors, they can be called by various names. They are disposable sensors, which are the type of sensors, examples of biosensors. Now, disposable sensors are the type of biosensors which are designed for the short-term use and spot analysis, on-time spot analysis and rapid and single-time measurements. So they are not 100% accurate sensors, like we couldn't be 100% sure about the results we have obtained, but to an extent disposable sensors, they are used for short-term use, rapid and immediate measurements. So that could be their advantages. So they are the type of sensors in which the transducer transduces the physical, chemical, biological changes in the environment into analytical signal or output. So this could also be said as they biodegrade and they are also sustainable. So they are eco-friendly and they have short duration of analysis. They provide digitalized chemical and biological information. They prevent the contamination of the sample. The sample remains contaminated. As I already said, biosensors are the type of sensor which have biological origin, in which our disposable sensors are one of its examples. And in our disposable sensors, we are going to study the detection of ascorbic acid using disposable sensors. What is ascorbic acid? We know ascorbic acid or ascorbate, which is the commonly known vitamin C. Yes, it is the commonly known vitamin C which is present in most of our fruits. Ascorbic acid or ascorbate, it is commonly known as vitamin C, and it is an important factor, it is an important soluble vitamin which is derived from fruits and other vegetables. Ascorbic acid improves the immune system in our body and enables collagen synthesis. It enables collagen synthesis, which is very essential to maintain healthy bones, body, skin, cartilage, etc. It also enhances antibody. It also enhances antibody levels and also acts as an antioxidant in our blood. So, ascorbic acid is a very vital and important vitamin which is required to our body. In the determination or the detection of ascorbic acid, we have many electrodes. This detection of ascorbic acid using disposable sensor is done using screen printed carbon. It is done using screen printed carbon on which electrode sensors are used. So on the screen printed carbon, the electrodes are printed using screen printing technology. So it consists of 3 electrodes. One is the working electrode and other is the counter electrode and other is the reference electrode. The working and the reference electrode are one and the same, which are the carboxyl MWCNT, which refers to the multi-walled carbon nanotubes. And all the electrodes are being manufactured by screen printing technology, as I already said, with the conduction material ink. Like the screen printing technology have been used with the help of conduction material ink on a plastic polyester sheet. On a plastic polyester sheet. Polyester sheet. So, let us now look into the working of electrochemical sensor in the detection of ascorbic acid by disposable sensor. So, the electrochemical sensor can catalyze the oxidation of ascorbic acid into dehydroascorbic acid. So, what is happening here is ascorbic acid is getting into dehydroascorbic acid, and how is it occurring? In the presence of oxygen. Now, let us look into the working of electrochemical sensor in the detection of ascorbic acid using our disposable sensor. The electrochemical sensor can catalyze the oxidation of ascorbic acid into dehydroascorbic acid in the presence of oxygen. Ascorbic acid is getting converted into dehydroascorbic acid in the presence of oxygen. The carbon multi-walled carbon nanotubes, the carboxyl MWCNT, which are used as the electrodes, they provide the media for the transfer of electrons between ascorbic acid molecules and the matrix interface. What happens next is it increases the electrocatalytic oxidation of ascorbic acid into dehydroascorbic acid, during which the transducer converts this presence into measurable signals. The electric current or voltage produced during the detection is proportional to the concentration of ascorbic acid present. So this tells us about the working of electrochemical sensor in the detection of ascorbic acid using an disposable sensor, where it is printed, polyester sheet is printed using screen printing technology. And the reactions are as follows, where ascorbic acid is getting converted into dehydroascorbic acid. As we know, pesticides are the organic compounds which do not degrade so quick in the soil. They are used in the killing or to eradicate pests from the soil, but they cause harm or ill effects to the soil. So detection of these pesticides is also a high concern. Hence, electrochemical sensors are used in the detection of pesticides, and disposable sensors are the examples of one such which are being used in their detection. So, in the detection of pesticides such as glyphosate by the help of disposable sensor, we use counter and reference electrode which are on the board. What happens is, we know synthetic chemical pesticides are supposed to be present everywhere, like because of their low concentrations of ppm and low biodegradability, they cause harm or ill effects to the soil. So due to the lack of proper knowledge, they are often used in large quantities without caution and precautionary measures. One of the most commonly used pesticide is glyphosate. This is the structure of glyphosate. So detecting this is a high concern. It has the ability to attach to the soil and degrade by soil microorganisms. It includes the chronic effects such as teratogenetic, tumorigenic, asthma, diabetes, birth defects, etc. In the detection of silicon-based chip is used. In the detection of glyphosate, we use a silicon-based chip which is used as a sensor. It consists of working electrode, counter electrode and reference electrode. The counter electrode and the reference electrode are on the board. The working electrode is gold. We use gold as the working electrode. What happens in the working of electrochemical sensor in the detection of pesticide is the electrolyte is added to increase the conductivity of the solution, and it also minimizes the resistance between the working electrode and the counter electrode. The working electrode which we have used is our gold, the counter and the reference electrodes. So electrolyte is added to increase the conductivity between the solution and to minimize the resistance between the electrodes. What happens? The electrochemical sensor catalyzes the oxidation of glyphosate on the surface of gold or our working electrode, or it is also called as sensing electrode. So what happens on the surface of gold is there occurs oxidation of glyphosate. Glyphosate is getting oxidized to form glyoxylate. Glyphosate is getting oxidized to form glyoxylate. How does it occur? A potential of 0.78 volt is applied on the working electrode. Gold is also called as working or sensing electrode, in which the potential of 0.78 voltage is maintained. And what happens next is a potential difference of 0.78 voltage is maintained on the working electrode or the sensing electrode, which is used as gold. Then what happens is the analyte interacts with the electrode surface. The glyphosate oxidizes on the surface of working electrode or on the gold, or it is also termed as sensing electrode. This causes change in potential, that is change in current. And what happens next is the change in current or the potential. It is directly related to the measurement of amount of glyphosate present in the solution. So the change in potential is responsible for the amount of glyphosate present in the particular solution, which gives us the concentration of pesticide present in that particular solution. This reaction shows the oxidation of glyphosate into glyoxylate. That is about the use of disposable sensors in detection of pesticides. So I hope you have understood the concept of sensors, its applications and its various needs, working, construction. So this is about sensors, chemical sensors, biological sensors, which work on the basis of different electrodes, different membranes, and that's all about sensors. Thank you.